Okay, so in this video I'm going to talk about conditional probability. So Tyler asks, what in the world is conditional probability, Mom? Remember when we were talking about dependent events? So if we have a dependent event, an example of that is when you take an M&M out of a bowl and then eat it, and then take another M&M out of the bowl. So if we're trying to find the probability of getting like a red M&M, there's one less M&M in the bowl and there's one less red M&M in the bowl. So that's an example of dependent events in probability. So when we're finding the probability of dependent events, we are finding the probability of A and B, which equals the probability of A times the probability of B given that A already happened. And conditional probability is this probability. Conditional probability is the given probability. For example, the probability of getting a red M&M given that I already got a red M&M out of my bowl. So the formula for a conditional probability, or this given probability, is you just take the dependent formula, the dependent probability formula, and you solve for the given probability. We would just take this formula, divide both sides by probability of A, and we would get the probability of A and B divided by the probability of A equals the probability of B given A. So this is the formula for conditional probability. In this video, I'm going to show you a couple of examples. One, finding conditional probability by just using this formula. Another example is finding probability, and some of them being conditional probability, using a Venn diagram. And then the last example will be finding conditional probability using a table. Okay, so here's our example of just simply using the formula. We're given that the probability of A equals 0.4, and we're given that the probability of A and B is 0.3, and we want to find the probability of B given that A already happened. So again, the formula is the probability of A and B divided by the probability of A. We just plug in what we know, which would be 0.3 divided by 0.4, and 0.3 divided by 0.4 simplifies to 0.75. Now you can get questions where you're using the equation that have percentages. So this is decimals. This is decimals. You might have a problem that uses percentage, and with the percentage, just turn it into a decimal, use the formula, you're all good. You also might get an equation or a problem where you're given fractions, and so it might be intimidating because it's fractions, but just put it into the formula, and I'll show you an example of something that you might have, like, well, I'll just take this example and put it into fractions. You would had 3/10 divided by 2/5, and when you have a fraction divided by a fraction, you flip the denominator and multiply. So this would equal, down here, 3/10 times 5/2, and then 5 goes into 10 2 times, multiply straight across, 3/4, and 3/4 is the same thing as 0.75. Sometimes you'll have a problem where they have the same denominator, and if they have the same denominator, those denominators are going to cancel, and it'll just be top numerator divided by bottom numerator as your probability. Okay, so let's do an example with Venn diagrams. Okay, so using a Venn diagram. So in this problem, we have a survey of 14 students, and we found that 7 like photography, 5 like design, 3 like photography and design, and 5 like neither. So the first thing I'll do is draw a Venn diagram of this information. So we have our little rectangle to represent our universal set, and we're going to have two circles that intersect because we have photography and we have design, and then some like both. So I know that 7 like photography, 5 like design, but 3 like both. 3 like photography and design. So I'm going to start with the 3 and put that in the middle where those two circles intersect. And then going back to photography, 7 students liked photography. So this whole photography circle has to add up to be 7. So the number that goes in here, just photography alone, is 7 minus 3, which is 4. Then design, the total number of students that like design is 5, but 3 of them like photography and design. So 5 minus 3 is 2. That's what goes right here, just design alone. And then 5 students like neither, so that goes on the outside. And so all of these should add up to be 14. Let's check. 4 plus 3 is 7, plus 2 is 9, plus 5 is 14. Yes, so here I have 14 students. Okay, so here are the probabilities that I want to find. First thing is I want to find right here the probability that a student likes photography or design. So this is in combined events, and if I have a Venn diagram with combined events, I just add up all the numbers inside the circle. So the probability that a student likes photography or design is equal to 4 plus 3 plus 2 divided by the total number of students, 14, which ends up being 9 out of 14, 9/14. So this is kind of review from previous sections. Okay, so the second probability I want to find is the probability that a student likes neither photography or design. Well, that's one of the values you were given, 5. So the probability that a student likes neither photography or design, so it's kind of like photography or design not, is equal to 5, this number all by itself, out of 14. Okay, so this one, the third problem, is the given probability. If I want to find the probability that a student likes photography, given that she likes design, what I do is I take the photography and design, and I divide it by the total design, total number of students that like design. So to find the probability that a student likes photography given that they like design, I take the combined, divided by the total design, which is 5. Now let me show you why that works. The formula for given in this situation would be the probability of design and photography divided by the probability of design. And that's what I did right here. I just took 3 divided by 5. Now 3, the real probability of design and photography is 3 divided by 14, right? There's 14 total students. And then the probability of design, students liking design, is 5 out of 14. But these 14s cancel. They're the same denominator, and you're just left with the numerators, which is 3/5. So if you have a Venn diagram, you can just think of this formula, not even deal with the denominator, and do the and divided by the total of the thing that already happened. So let me show you how this works on the fourth one. If we want to find the probability that a student likes design given that they like photography, we're going to take the probability of the and divided by the probability, we're going to take the and divided by the total photography. So we take and divided by total photography, 3/7. Again, your numerator is going to be the and, where they're combined, and your denominator is going to be the total of this total circle of what already happened. And so in this case, the photography already happened, and the number 3, the design already happened. All right, let's do our last example that involves a table. Okay, so here's an example. Okay, So say I went out and I collected data on what tie color somebody is and what math course they're in. So I went out and I sampled a bunch of blue ties and asked them what math class they're in, and then I sampled a bunch of yellow ties and asked what math class they're in. And I want to find all these probabilities down below. So the first thing I need to do before I find any of these probabilities is total all the columns and the rows. So let me do that right now. Okay, so now that I've totaled all the rows and the columns, and I totaled everything all together, I can find these probabilities. So for the first problem, say I want to find the probability that a student is in math studies. Well, I just look at the math studies column, and I look at the total. There's 21 students that are in math studies, and then I divide that by the total number of students. So that would be 21/67. For the second problem, if I want to find the probability that the student is a blue tie, I just look at the blue tie column, or blue tie row, and there's 29 blue ties, and I divide that by the total number of students that I asked. So 29/67. For the third problem, I want to find the probability that a student is a blue tie and is in math studies. Okay, so for the next problem, if I want to find the probability that a student is a blue tie and is in math studies, I just look at the intersection of math studies and blue tie. So there are 8 students that are blue ties and in math studies. So I take that number and I divide it by the total. Okay, the fourth problem is when I have the given probability. If I want to find the probability that a student is a blue tie, given that she is in math studies, I could use the formula. So let me show you what I would do. The probability that a student is a blue tie, given that they are in math studies, would be the probability of that they were in math studies and blue tie divided by the probability of math studies, which I think I found those. I would get blue tie given math studies would be 8/67. I didn't give myself much room here. And then the probability that a student is in math studies would be 21/67. And so those 67s cancel, and I would be left with 8/21. So that's how you would find the given probability with the formula. But there's another way to find the given probability if you're given a table. You would so to find the probability that a student is a blue tie, given that she's in math studies, what I do is you only look at the math studies column. You only look at the event that already happened. So the math studies already happened. And within that column, you look at the probability you're trying to find. So in this problem, I'm trying to find the probability that a student is a blue tie. So I take this number, blue tie, 8, and I divide it by 21. And so that's the same probability as using the formula. So for the fifth problem, we'll use this little shortcut as our way of doing it. If I want to... And I'm interrupted by Mr. Hansen. I'm recording a video. It's okay. No, it's okay. Okay, so using this shortcut to find the probability that a student is in math studies, given that she is a yellow tie, I will just look at the yellow tie row, and so there's 38 yellow ties, and then the fact that they are in math studies is 13, so I just do 13 divided by 38, and that's the answer for this problem right here. Okay, that's it. Good luck on the practice problems.